Hi, everybody. So I'm going to be talking about the role of judgment and interpretation in nutrition research. And I'm funded by the Noakes Foundation and the National Research Foundation of South Africa. And my food bias is I eat whole foods and value personal experience. And that translates into a low-carb diet. All right, so I've been involved with low-carbohydrate diet research for about 7 years now. And I've found nutrition in general to be quite a challenging space. And part of the difficulty is there's this strong, persistent message that the healthiest way to eat is already known. And I think the very existence of dietary guidelines and dietary policies, it implies that there are at least some definitive answers in nutrition. And it implies that there's sufficient certainty and sufficiently strong evidence to justify promoting certain ways of eating. But my experience has been quite different, and I found nutrition research to be filled with inconsistencies and contradictions and double standards. So some of the questions that arise from this is, how much certainty is there in nutrition research? And why is there so much contradictory information? So how is it possible that everything from an all-meat diet, carnivore diet, to an all-plant diet, vegan diet is promoted? And what does this mean for patients and clinicians? So to address this, we're going to take a look at the quality of research and what this term quality means. And then the two study designs which have had the biggest impact on what we're told about nutrition are randomized control trials and observational studies. So we'll take a look at both of these studies and the relationship between them. So evidence is often ranked according to quality. And in this example, the evidence hierarchy is presented as a pyramid, where at the top of the pyramid you have the highest quality evidence. And generally, the higher quality evidence is difficult to produce, so there's less of it. And then as you go down towards the bottom of the pyramid, there's more evidence, but it's of a lower quality. And this is usually done when people are trying to formulate recommendations, and you have to compare and synthesize studies which have different strengths and weaknesses and different designs. And then the assignment of quality is really important, because evidence which is considered to be of a higher quality will often have a bigger impact on the advice we're given. And typically in nutrition, the evidence hierarchy looks something like this. It's expressed according to research design. So at the top of the pyramid, you have your systematic reviews of long-term randomized control trials with hard disease endpoints. And then individual long-term randomized control trials with hard disease endpoints. And in this middle area, you'll see study designs like short-term randomized control trials with intermediate health markers, prospective cohort studies, non-randomized control trials. And at the bottom, things like other observational designs, case studies, clinical reports. All right, so design, I think, is a useful proxy for quality. But what I want to try and emphasize in this talk is that what gives research its quality is how open it is to interpretation. So this top quality research in that green area, it's research which has minimal possible interpretations. And it leads the researcher and the readers to clear, unambiguous conclusions. And then as you go down the pyramid into the gray and the black area, it becomes more ambiguous, and interpretation is actually required to make any conclusions. And this is an important distinction, and there are many examples in medicine where supposedly weak study designs have contributed to, produced high quality evidence. And just as one example, a key study in the proof that stomach ulcers are caused by bacteria, and that was a case study. And this was, of course, the famous experiment where Barry Marshall deliberately infected himself with H. pylori. And then he developed an ulcer over the next few days and was able to treat it successfully with antibiotics. And as a second example, the relationship between smoking and lung cancer. So the proof that smoking causes lung cancer, it's predominantly based on observational data, so supposedly weak data. So Barry Marshall's case study, and the relationship between smoking and lung cancer, those studies sit at the top of this evidence hierarchy, even though they are supposedly weak study designs. Right, and with that in mind, let's take a look at nutrition research. And we'll start with randomized control trials. These are considered the strongest form of evidence because they have some built-in controls. So participants are randomly assigned to an intervention and a control group. And in an ideal situation, the only difference between groups is the intervention, the thing you're studying. And then if you see changes, if you see differences in the outcome, you can attribute that to the intervention. But there's some problems specific to dietary randomized control trials. And the first one here is they're best suited to focused interventions. So they're most useful in evaluating the average efficacy of a single, simple treatment assumed to have few known confounders. All right, and if we take a look at nutrition research, it looks something like this. The goal is to figure out how the foods you're eating affect disease, so diabetes, heart disease, these long-term health outcomes. But unfortunately, there are a few things in the middle. So food has to be quantified, it has to be measured and estimated, and there are a lot of problems in that step, which I'm not actually going to talk about. But another problem is that the components of food are all highly interrelated. So for example, even a relatively simple intervention, like if you wanted to increase egg consumption, as soon as you do that, you increase cholesterol, choline, fat and saturated fat, energy, and often you want to keep energy constant in the controlled diet, so you'll have to take something out, and then everything that's part of that food will come out. And then in complicated interventions like a ketogenic diet, if you're comparing a ketogenic diet to a whole food plant-based diet, there's so many differences, there's so many additions and subtractions and interactions in those two interventions that it becomes really difficult to even know what you're trying to study. Then when you eat food, you have an acute response. So this would include things like digestion, absorption, and a metabolic hormonal response. And this is highly individual. It's also specific to nutrient combinations and timing of eating. So egg and bacon in the morning could be different to eggs in the morning and then bacon later in the day. So same food, different response. And then over time, these acute effects accumulate into chronic effects and then ultimately into disease. And this process takes many decades, it's complex, and also it's highly individual. And the relationship between the chronic effects and the health markers, things like insulin resistance, obesity, also complex and interrelated. And this is where you start getting into problems. You hear often in low-carb research that it's a low-carb randomized control trial, but oh, they lost weight, that's why you've seen the benefit. So these things are all interrelated. And then just to complicate things further, in any lifestyle research, there are all these other factors, these confounders that play a role. Things like exercise, stress, sleep, and there are many others. So when it comes to dietary randomized control trials, it's difficult to isolate the intervention. And then it's really hard to control for all of the complexity and individual variation that exists in the middle. So randomized control trials they're on the back foot from the get-go. Second big problem is dietary trials. They place a large burden on the participant. So often the participant has to shop and cook and maintain this behavior change for months or even years in the longer trials. And often in the same environment where they develop their bad habits in the first place that you're trying to change. So you can see why this is an incredible challenge for the participants. And in dietary randomized control trials, compliance is usually very poor to control and intervention groups, and the attrition rates are very high. And then blinding is not possible. And I think this is a really important point, because blinding and randomization are actually, they're interlinked, they work together. So imagine signing up to participate in a research study investigating the effects of carbohydrate restriction in type 2 diabetes, and then you get assigned to the control group. All right, so now you have to eat no more than 30% fat and make sure you're getting your healthy whole grains. So you can see how, as soon as you know which group you're in, this affects the behavior of the participants as they go forward in the trial. Very commonly, control group participants lose motivation and often just adopt aspects of the trial which attracted them to the study in the first place. And then intervention participants are carrying all sorts of expectations into the trial. It's not really, the specifics not that important, but the point here is that randomization, the point of randomization is to try and reduce bias and confounding by randomly distributing it between groups. But if you can't blind, you're just reintroducing a whole lot of bias and confounding. It might be different, but it's not, the effect of randomization is less complete. And I think this raises a really interesting question, which is what is the value of randomization versus non-randomization when blinding is impossible? And then, so for example, a study like Verta Health is a non-randomized control trial. And is it reasonable that Verta Health is excluded from, it's not included in systematic reviews, and it's generally considered low evidence by people who rank evidence for guideline purposes, and that's because it's a non-randomized trial. And then last problem with randomized control trials is the results are very specific to the populations, the timeframes, and the control groups that have been tested. So this is it's called external validity. It's difficult to translate the results into the real world. So this is particularly problematic in short-term randomized control trials, and that's because the relationship often between the health markers that we're measuring and the outcomes we're ultimately interested in is complex and unknown. And also there's a lot of disagreement over which markers are important, as you've seen in this conference, but there are people who think LDL is an important marker. So, all right, so here's two examples of short-term randomized control trials, and this is just to highlight some of the ambiguities in these studies. So on the left, we have one by Nuttall, 2015, and this was a randomized crossover trial. So the participants served as their own control. The diet was 3% carbohydrate, so it's a very low carbohydrate diet. And what's important in this study is the patients, it was an inpatient study, the patients were provided with food. So the researchers are 100% certain that the participants are complying to the diet, and what they're actually studying is the effects of the diet on metabolism. And they were able to make quite a specific conclusion relating fasting to low-carb diets to blood glucose control. Right, and then the study on the right, Iqbal, it's a randomized control trial comparing low-carb and low-fat. More participants, and the target diet was a very low-carbohydrate diet, 30 grams per day, and it was a 2-year intervention. It was a low-intensity intervention that consisted of weekly education sessions for the first month, and then monthly education sessions for the rest of the trial. But in this particular study, there was no point, including the first assessment, which was at 6 months, at no point did the participants actually change their diet. So it's not clear why. It's not clear why that happened, but the reality is they didn't reduce their carbohydrate intake from baseline. So the question arises here, the study on the left, how does a 3-day study relate to permanent lifestyle change, which is what you're ultimately trying to do as a physician? And then the study on the right, what does this actually tell us about carbohydrate restriction? What does a study where there's been no change in diet tell us about carbohydrate restriction? And so the Iqbal study is frequently included in meta-analyses of randomized control trials. And it's one of the studies that's often cited as evidence that low-carbohydrate diets are difficult to sustain. And that's because the participants were given a target which they didn't meet. All right, long-term randomized control trials. So this would be conventionally in that top of that pyramid, highest quality evidence. And there aren't very many of these, but here are 3 of the biggest ones. The Women's Health Initiative, Multiple Risk Factor Intervention Trial, and Look Ahead. So you can see large participant groups and 7 to 10 years. Importantly, the main outcome measures here are these long-term heart disease endpoints. So cardiovascular disease, coronary heart disease, mortality. And the diets that were tested in these trials, it's the dietary guideline diets. less than 30% fat, less than 10% saturated fat, reduced cholesterol, increased fruit and vegetables. So that was the dietary component of the intervention. But in none of these trials, and the trend in these long-term studies, the intervention had no effect on the main outcome. So these interventions failed to make a difference compared to the control. So there are a number of possible ways that this has been interpreted. For example, the intervention was not intense enough. We need to lower fat even more. The intervention actually worked. So even though you didn't see differences in the heart disease endpoints, patient quality of life was maybe better, or intermediate health markers had improved. Event rates were lower than expected, and this is because the control group was advised to stop smoking along with the intervention group, and the event rates dropped, so maybe the studies were underpowered. Long-term randomized control trials, there's a lot to overcome, as I've mentioned just now about how difficult these trials are. Maybe it's just not possible to do these types of trials. And potentially the hypothesis is wrong. Maybe the dietary guidelines can't actually reduce event rates. So again, the important point here is not which of these is right or which combination of interpretations is correct. The point is that far from reducing available interpretations, these long-term randomized control trials, they're actually wide open to interpretation. And instead of clarity, these trials have added confusion to the literature. So in terms of reducing the need for interpretation, I think it's quite difficult to justify that long-term or short-term randomized control trials are in that top area, in that green area. So they're somewhere in that gray area. All right, observational studies. So observational studies have much less built-in controls than randomized control trials, and they're a weaker design. But in nutrition, they're often treated as though they provide the highest quality of evidence. So they almost treat it as though they like smoking and lung cancer. And observational studies have had a very large impact in informing dietary advice. And this is the advice that's being propped up by observation. I'm using that phrase propped up because I don't really think that if you look at all the observational studies, that it actually takes you necessarily to this. But it's essentially the dietary guidelines that you're all familiar with. The big question in observational studies is, can nutritional associations be interpreted as causation? So is association causation? And this was the problem that Bradford Hill famously tried to address in 1965. And he presented a possible way to approach this. So he presented 9 principles which outline a framework to think about the likelihood that an association is causation. And these are his principles. His approach in this was very thoughtful. He emphasized that none of these principles by themselves can actually answer the question. And the ultimate aim of the process is to think about all the available data and to provide guidance on the interpretation of associations. So the two you may be most familiar with are strength and consistency. And nutritional associations are weak in general, with hazard ratios between 1 and at most like 1.4. And then also inconsistent, so you get eggs are good and then bad and then neutral. That's common in nutrition. So the 3 I'm going to focus on are these 3. They tie in with what I've said so far. So specificity, coherence, and experiment. All right, so specificity, it can refer to the directness of the relationship between the exposure and the outcome. And the more direct the relationship, so the more specific, this adds weight to a causal interpretation. And as you saw earlier, nutrition exists in this complex system. So there's a decades-long time lag between the exposures, which is the diet, and this is forgetting other problems like measuring diet. So there's a decades-long time lag between the exposures and the outcomes, and then you've got all the complexity of the nutrient interactions, the individual responses, the individual variation, and all of that in between the exposure and the outcome. And then another problem with observations is all of those other factors, the confounders, they have to be accounted for with models or with statistical adjustments. And this is a big problem because they are poorly measured or not measured or unknown, kind of like diet in these studies. So nutrition is very non-specific. All right, coherence. So I think this is a really important principle. And the point here is, are these associations coherent with other bodies of evidence? And this is where results of short-term randomized control trials are quite important. And there are a lot of short-term randomized control trials that have tested low-carbohydrate diets, at least 150 that I know of. With very few exceptions, the lower carbohydrate group either outperforms or is equivalent to the control group. So at worst, carbohydrate restriction is equivalent to the control. And then there's, as we've seen this weekend, there's evidence for benefit in HbA1c, body weight, lipid profiles, type 2 diabetes, medication reduction, fatty liver. No evidence of harms, adverse effects, or nutritional inadequacies from the randomized control trials. No evidence that exercise capacity or strength is reduced. So while these short-term randomized control trials, they may fall short of conclusive scientific proof that a low-carb diet is safe and effective, the body of evidence is incoherent with the observational studies. It's incoherent with the hypothesis that this diet is harmful. And then what about all of this other evidence? So non-randomized control trials like Verta Health. And then we did a study in participants who'd self-selected a low-carb diet. And their diet was high in saturated fat, high in animal products, and they'd reversed their type 2 diabetes. And then things like case studies from practicing clinicians who are reporting really good outcomes by directly ignoring the guidelines. And the last two on that list are actually carnivore diets. So coherence is acknowledged in the literature, and in low-carbohydrate studies, controlled trials, you'll often see this. Low-carbohydrate diets have been associated with negative long-term health outcomes. Our findings should be interpreted with caution, and long-term studies are needed. So you see that everywhere. But what you never see, and which I think should probably be more common in the observational studies, is something like the reported associations conflict with the body of evidence from short-term randomized control trials and clinical reports. This lack of coherence potentially weakens the argument for causation. All right, and then experiment. So Hill said the best way to confirm that an association was causation would be direct experimental testing of that hypothesis. And as mentioned earlier, this has been attempted with long-term randomized control trials that were specifically designed to test dietary guidelines. And they were open to interpretation, but I think it's fair to say direct experimental testing has not confirmed causation for these associations between dietary fat and cardiovascular disease. Hill also spoke of a natural experiment, and this is where something in the environment changes and you study changes in outcomes. And we've had a natural experiment in nutrition since the late 70s, early 80s with the low-fat dietary guidelines. So this is when low-fat diet was promoted to the public. And I'm sure you're all familiar with this. There's been sharp increases in obesity, diabetes, and other chronic diseases within 10 years of this advice. Right, so none of these principles rule out that the associations are causation. But in each case, they just raise a red flag about interpretation. So nutritional observational research is non-specific. The observations are incoherent with large bodies of evidence. The observations supporting dietary guidelines have not been confirmed with long-term randomized control trials. And results of the natural experiment promoting low-fat diets have been unfavorable, to be kind. And so my personal evaluation of the observational studies is that there are a lot of reasons to be very cautious about interpreting these associations on face value as causation. And again, personally, I don't find this body of evidence useful in informing my personal dietary choices. All right, so coming back to the initial questions, is there certainty in nutrition research? And as we've seen in at least the trials I've spoken about, the answer is no. Randomized controlled trials and observational studies are ambiguous, and this is due to some of the properties that make nutrition research inherently very difficult. So the perception of certainty, the guidelines, the policies, this perception of certainty does not reflect the reality of nutrition research. And then why is there so much contradictory information? I think a lot of the contradictions are coming from different interpretations and different valuations of the same evidence. So people are looking at the same studies and just taking different things out of them. And then what does this mean for patients and clinicians? So firstly, I think really important, no study can tell you how to eat. The research is your guide, and it's a really useful guide, but ultimately, personal experience and clinical experience have to play an important role. And one of the big challenges that clinicians face is this conflict between the idea of a best practice, proven diet, and the poor outcomes that are often seen in practice. And then patients also losing faith in lifestyle management. But if you look at the entirety of the available research, exceptional health outcomes are possible, and at this conference we all know that. So I'm going to end off with a challenge to clinicians. Try to engage directly with the research. So try to see the real research. And then trust your clinical experience and your personal experience and your professional judgment in interpreting this research. Great, thank you.